Okay, welcome to Chapter 9 of Introduction to Statistics. In Chapter 9, we're going to be looking at different statistical tests when we have two different populations. And so when we have two different populations that we are looking at, we might be asking, does one population have a bigger average than the other population? Or is one population, do they have a higher percent of something than another population? Or things like that. On our flowchart for chapter 9, we're mainly going to be using this second branch right here of I am comparing two samples. And so on the test, when you need to know which test to use, just remember that if you have two samples, you're going to be using this branch down here. If you have three or more samples, we'll be doing this branch, which we'll talk about later. But for now, just keep in mind, if you have more than one sample, we'll be using this branch down here. So let's just check out what a problem might look like. Here it says, a newspaper published an article about a study in which researchers subjected laboratory gloves to stress. Among 233 vinyl gloves, 60% leaked viruses, and among 233 latex gloves, 9% leaked viruses. And so, according to this, use the technology results and a 10% level to test the claim that vinyl gloves have a greater virus risk leak than latex glove. Now, unfortunately, again, I forgot to include the test results. So luckily, it's pretty easy though. So I'll just put it like here. What you might see something like this is p hat 1 equaling something like 0.60, p hat 2 equals 0.09, n1 equal 233, n2 equal 233, z equaling something like 11.710382, and p equaling 0.0000. So this is kind of what you might see in your technology display, something like this. Now, remember, I know this is difficult to read. Don't forget I've uploaded these blank notes as well as the filled out notes to the class website, so make sure you, to D2L, so make sure you please look at that. Okay, so the question is, what is our null hypothesis and what is our alternate hypothesis? So first off, I hope you recognize that what we are talking about here is we are talking about a proportion, because what we're looking at is the percent of gloves that leaked virus, and so we would be using these proportion tests down here. And what you'll notice down here about the proportion when we're using two samples is that the two samples are on both sides of the hypothesis test. So our null hypothesis test is going to be that the two proportions are equal to each other, and then our three choices for the alternate hypothesis is that the two proportions sample means aren't equal to each other, or that one is bigger than the other. Okay? And so that's what we're going to be doing with these hypothesis tests. So the null hypothesis test, as you know, always involves an equal sign, and if we have two proportions, the two proportion samples, then the null hypothesis is that the two sample proportions are going to be equal to each other. That's our null hypothesis. That, in a way, is what we are trying to disprove. So here it says, remember that our default alternative hypothesis test is that the two proportions are not equal to each other. But let's see if it says something about greater than or less than. Here it says, test the claim that the vinyl gloves have a greater virus leak rate than the latex gloves. So that means we're testing the hypothesis that one group is bigger than the other. Notice then it says, let vinyl be population 1. So we have population 1, population 2. And so because 1 is vinyl, and we're testing the claim that vinyl is greater than latex, then that means it would be a greater than sign here. So our alternate hypothesis is that the first proportion is greater than the second proportion. With proportion hypothesis test, the test statistic is a z-statistic, and you can see that we get it from over here. It would equal 11.71. And identify the p-value 0.0000. And I know that's tricky because there's a lot of p's running around. Remember, our p-value is hopefully a very small number. If it's small, then we're probably going to reject the null hypothesis. These two p-hats are the two samples of 60% and 9%. Those are the two sample proportions. You can see how much bigger one is than the other. I mean, it's way bigger. So we get z-score of 11.7, and again, you can sort of kind of think of that as 11.7 standard deviations, which is just off the charts, and so we get a p-value of 0.0000 as a result. So it is okay to put 0.0000 in as your answer. It's not equal to 0, it's just a lot of zeros and then a 1. So for rounding purposes, it's effectively 0.0000. You can see that that's way less than our alpha, which is 0.10. So because the p-value is less than the significance level alpha, we reject the null hypothesis. I would say there is sufficient, I think is the word they're looking for, but I would say strong, evidence to support the claim that vinyl gloves have a greater virus leak rate than latex gloves. So everything else that we learned in Chapter 8 is pretty much the same thing. If our p-value is less than alpha, we reject. If the p-value is greater than alpha, we fail to reject. Unfortunately, the formulas for two proportions are kind of long, so I'm going to stop this video here. In the next example, we'll look at a full example with, and again, they would have given you all of this, so I didn't come up with these numbers from nothing. Assume that they had given this to you. In the next video, though, we'll look at how to come up with these numbers ourselves, and I will see you there.